Good morning, good afternoon or good evening guys. Our lesson for today is distinguishing error types in Java. Knowing when an error can occur is important. You need to understand when to look for a particular problem in your application. However, it's also important to understand how errors occur. The kind of error determines the strategy you use to find it and what you can do to fix it. Although some errors will require that you fix the code and update the application, some errors are fixed by retrying the operation or interacting with the user in some way. The following sections discuss the types of errors that you'll encounter most often. First is syntactical errors in Java. A syntactical error in Java code is one in which the language you use to create your code is incorrect. For example, if you try to create an if statement that doesn't include the condition in parentheses, even when the condition is present on the same line as the if statement, that's a syntax error. The compiler will catch most of these errors for you. If the syntax of your code is incorrect, then in most cases the compiler can't use the code to create bytecode for the JRE. Here's a list of the most common syntax errors. Using incorrect capitalization. One of the most common syntax errors that new developers make is to capitalize keywords, rather than use lowercase. Java is case-sensitive, so using the proper case when you type your code is essential. This same error can occur with class names, variables, or any other code you type as part of your Java application. A variable named myvar is always different from one named myvar. Splitting a string over two lines. In most cases, Java doesn't care if your code appears on one or more lines. However, if you split a string across lines so that the string contains a new line character, then the compiler will object. The answer is to end the string on the first line with the double quote. Add a plus sign to tell the compiler you want to concatenate. Add this string with another string, and then continue the string on the next line like this. Missing parentheses. If you make a method call and don't include the parentheses after the method name, even if you aren't sending any arguments to the method, the compiler registers an error. For example, this code is incorrect because print requires parentheses after it. Forgetting to import a class. Whenever you want to use a particular Java API feature, you must import the associated class into your application. For example, if your application contains string username, then you must add import java.lang.string to import the string class. Treating a static method as an instance method. Static methods are those that are associated with a specific class, while instance methods are associated with an object created from the class. Missing curly braces. Anytime you want a Java feature to apply to multiple lines of code, you must enclose the entire block within curly braces. In most cases, the compiler will catch this error for you. For example, if you try to end a class without including the closing curly brace, the compiler will generate an error. This is one error where the compiler may not show you the precise location of the error because it can't detect where the curly brace is missing. It simply knows that one is missing. This sort of error can also create runtime errors. For example, when an if statement is supposed to apply to multiple lines of code, but you leave out the curly braces, the if statement affects only the next line of code, and the application works incorrectly. Forgetting the class or object name as part of a method call. You always include the class or object associated with the method before making the method call. For example, character.toUpperCase and system.out.print are correct, but simply calling to uppercase or print is incorrect. Omitting the break clause from switch statements. It's easy to forget to add the break clauses to a switch statement. In addition, the compiler won't catch this error. As a consequence of leaving out the break clause, your application will continue to execute the code in a switch statement until it encounters a break clause or the switch statement is complete. Omitting the break clause from switch statements. It's easy to forget to add the break clauses to a switch statement. In addition, the compiler won't catch this error. As a consequence of leaving out the break clause, your application will continue to execute the code in a switch statement until it encounters a break clause or the switch statement is complete, omitting a return statement. When you create a method that's supposed to return a value and then don't provide a return statement to return the value, the compiler will complain, mistyping the header for the main method. The compiler won't complain about this problem, but you'll see it immediately when you try to start the application. Java will complain that it can't find the main method. Next is semantic error. Many people find the difference between semantic errors and syntactical syntax errors in Java code hard to understand, but they are different. You can see a semantic error when the syntax of your code is correct but the code usage isn't correct. The most common semantic error is one in which the code uses a variable that isn't initialized properly. Fortunately, the compiler finds this particular semantic error in most cases. Here's a list of other common semantic errors you need to know about. Using an operator that doesn't apply. In some situations, you might try to use an operator that doesn't apply to the variable or variables in question. For example, you can't use the increment operator, with the Boolean variable. Newer versions of Java have become adept at finding this error, but you can still encounter difficulty figuring out precisely why an error occurs when you use the wrong operator in some cases. For example, myObj1 equals myObj2 won't compare the two objects. The equality operator works only with primitive types, using incompatible types. This type of semantic error can be tricky because the compiler will flag some errors and not others. For example, if you try to assign a float to an int variable, the compiler displays an error message. On the other hand, if you assign an int to a float variable, the compiler performs an automatic type conversion to the int to make it a float. The problem with this second scenario is that it can silently introduce errors in your code, especially if you really did mean to use a float. Losing precision during a conversion. Sometimes you can apply casting incorrectly. For example, casting a float to an int works fine, but at the loss of the decimal portion of the number. This loss of precision can affect the output of your application in unexpected ways and cause the output to reflect the value other than the one you expected. The compiler never finds this sort of error because you have specifically applied a cast to the variable and the compiler expects that you know what you're doing. Performing an impossible cast. It's possible to convert between many different types in Java. However, no matter how much you'd like to convert a Boolean value into an int, Java won't let you do it. The concept of performing the cast is syntactically correct, but you're applying it incorrectly, making this a semantic error that the compiler always catches. Applying scoping incorrectly. Any variable you declare inside a method has the same scope visibility to other parts of the application. In other words, as the method. Consequently, you can't declare a private static int variable inside a method. Thank you for watching. For more questions, just chat in our group.